Whenever you see a quadratic function graph, that parabola, when it intersects the x-axis, and if it's going to intersect the x-axis, right? If it's pointing up or down, it's going to hit that x-axis as it heads up or heads down. Now there are 2 points at which it hits the x-axis, and these are called the zeros of the function when you set f of x equal to 0. Now, if you remember in our last lesson, we talked a little bit about factoring a quadratic. And the reason you factor is so that you can find the zeros of that function. So I'm going to start here with x squared, and we're going to take a look at we know it's going to be a parabola, right? So we've got x squared minus 5x plus 6. So we've got a parabola here, as we know, and we've got 2 points here where it hits the x-axis. These are the zeros. So 2, 0 and 3, 0 are the 2 points at which it hits the x-axis. So how do we know those? So if we know the vertex and we know where it's going to hit the x-axis, those zeros, we can sketch out that parabola anyway. So let's go and look to see what is happening, how we get those zeros through factoring. All right, so here we have our quadratic. We graphed it first just so that we could kind of see what was going on. But we have it as x squared minus 5x plus 6. Well, let's factor this out and then let's solve for x. So we've got 6 and 1 are factors of 6, right? And 3 and 2. So if we take 6 and 1, we've got to get a positive number over here. So negative 6 plus negative 1 is going to be negative 7. So it looks like we're going to use 3 and 2, right? Negative 3, negative 2. So your factors are x minus 3 and then x plus 2. So that's what we ended up with. So we've got x plus 3, x minus 3 and then x minus 2, because what I said was we've got to get a negative 5 in the middle. So that's the way we're going to get it. So x minus 3, x minus 2. So we've got x minus 3 equals 0, and we've got x minus 2 equals 0. So x equal 3 and x equal 2. So this parabola is going to hit the x-axis at 3 and 2. So let's go and check that. We hit the x-axis at x equal 2, and we hit the x-axis at x equal 3. So that's how you can solve for those zeros and know where that parabola is going to intersect that x-axis. Now we can solve a quadratic equation. We can use a table like we did in Desmos, but what we want to do is find the solutions for this quadratic. And I want you to just simply use Desmos. But if we have an equation at 5x squared plus 30x plus 14 equal 2 minus 2x. Well, we want to set it equal to 0, so we're going to subtract 2 and 2x from both sides, right? So we've got 5x squared plus 30x plus 2x, because we're bringing it over, plus 14 minus 2 equals 0. All right, let's combine here. So we've got 5x squared plus 32x plus 12, and we've got that equal to 0. So we've got a quadratic. So you can get you a table of values and get that into there and see what your solutions are. So, or you can just go, once you combine like terms, go and graph it, and let's see what your solutions are for your x values, your zeros, right? Or you can simply go in there and factor this out and figure this out. So getting a table is not as valuable necessarily as it is getting a better understanding of what's happening. So we know through our standard form, we got it here in standard form, that it's gonna go up, and let's see what our zeros are when we're over in Desmos. All right, so let me get this one gone here. So we ended up with 5x squared plus 32x, so 5x squared. Let's see where those zeros are. Plus 32x plus 12. All right, so we've got a parabola that's pointing up. We knew that because of that 5. We know it's going to hit the x-axis at 12, right? We know a lot about these things already. So there it is, 0, 12. All right, so we've got our intercepts at negative 6, 0. So x equal negative 6 is one of your zeros. And then x equal about negative 0.4 is your other zero. So I would simply just have an understanding of how this happens and then let Desmos do the work. Just, if you went and factored it, or if you created a table of values and solved for it, you could actually get yourself over to 0. So if you created a table of values and you gave your y value a 0, because it's not gonna be anywhere but 0, right? You could then substitute back